Hello, good evening, everyone. So, this is our research about development of precise measurement of water percolation inside the infiltrometer for supporting plant water requirement analysis.
We would also like to introduce ourselves. There are Reza Arya Piradiansyah, Gabriel Lidasyah Putra, and I am Ulfa Dwi. We as researchers were also accompanied and supervised by Mr. Andri Primanugroho and Mrs. Dr. Mutinirum. Next. Agriculture is one of the dominant sector in income community and has an important role in Indonesia because the majority Indonesian work as a farmers. Development substance of agriculture is highly expected in an area in this case. The role of the government is very much needed in agricultural development, especially to facilitate the facilities and infrastructure needed by the farmers themselves. Irrigation is one of the important factors in agricultural activities in a broad sense. In accordance with the definition of irrigation itself, the purpose of irrigation in an area is an effort to technical engineering for the provision and regulation of water in supporting the process of agricultural production, from water source to area in need and distribute the technically and systematically. Next. These are more efficient irrigation systems that were invented in recent decades. This help us to use water economically without waste for agriculture. The system is called Irrigation Modernization, which is an effort to implement a participatory irrigation management system to achieve an efficient and effective level of irrigation service, increase security, reliability, water supply, infrastructure, irrigation management agencies, and also human resources. Irrigation modernization is needed to support efficient use of water in irrigation because the condition and function of national surface of irrigation infrastructure are not yet optimal. Next. In a conventional irrigation system that uses primary irrigation channels and dividing channel, it is needed very difficult to regulate the entry of water discharge into agricultural land according to the wishes and needs of plants. In addition, the weakness in the conventional irrigation system is that there is no tool used to measure the water loss that occurs during the irrigation process or when water has been flowed to the plant land in real time. And also in conventional irrigation, there is an infiltrometer that is useful for determining vertical seepage of water into the soil, but that is not effective due to several reasons, such as inaccuracy of the officer in reading the water drop in the infiltrometer every period. And also has another weakness is that an ordinary infiltrometer is very difficult to use for continuous process. This is based on the fact that the water level monitoring process can take several minutes or hours every day. The officer on duty at the infiltrometer certainly cannot monitor and calculate any decrease that occurs in the infiltrometer due to the limitation in working hours. Next. So we need an equipment that supports it, where the monitoring system has been developed using ultrasonic sensor bias and lasers. So the purpose of this research is to develop an automatic water level monitoring system using a specific tool called an ultrasonic sensor on a double ring infiltrometer with higher accuracy and stability. Because observation and measurement of water level with conventional methods has a high risk of human error and it's not effective. Next.
How does the ultrasonic sensor work? Ultrasonic sensor work by sending out a sound wave at a frequency above the range of human hearing. The transducer of the sensor acts as a microphone to receive and transmitter to send the ultrasonic sound. Next. Some of the supporting equipment that need to be prepared for a real-time observation are one iron frame and next not MCU, sensor max Baltic MB73i9, jumper cable, laptops, stopwatch, internet network, power source. Next. The ultrasonic sensor read the water level in ring infiltrometer and then processing by C++ code and send with Wi-Fi connection into cloud server, and the result will become the water level value.
So this is the result of observation and estimates water level reading. So here are the result of observation and estimate water level reading with the millimeter unit sensor with sensor 30 centimeter above the water surface. So based on the graph, we get R square is 0.9902. Then the result of observation and estimate water level reading with the sensor 40 centimeter above the water surface. Based on the graph, we get R square is 0.9972. The next is result and observation and estimate water level reading with the sensor 50 centimeter above the water surface. So we get R square is 0.9979. The next is observation and estimate with the sensor 60 centimeter above the water surface. So based on the graph, we get R square is 0.9941. The next is with the sensor 70 centimeter above the water surface. We get R square is 0.9977. The next is sensor 80 centimeter above the water surface. So based on the graph, R square shows as 0.9935. And then the result of observation estimate with the sensor 90 centimeter above the water surface. And we get R square is 0.9967. And the last is result of observation and estimate water level reading with the sensor 100 centimeter above the water surface. We get R square is 0.98 and 94. So the best result are obtained when the sensor is 50 centimeter above the water level with the R square is 0.99, RMSA is 1.2 millimeter, and MAPE is 0.52%. So the conclusion is the precise measurement of water percolation inside the infiltrometer using an ultrasonic sensor works optimally at a certain height because the water level reading is strongly influenced by the characteristic of the sensor wave. So that's our research. Thank you for everyone.